Hey all, I'm going to do a review here for the next benchmark, benchmark 3. Just like the other benchmark reviews, skip ahead, fast forward, go back. Only look at the ones that you really need help with, so you don't have to watch the whole thing. Start here with number 1. You want to find the midpoint of segment AB that has these points A and B. So we're finding the midpoint. So we'll start with the midpoint formula. Remember, you should write the formula every time you use it. Remember, there's no equal sign. This is the name of the point, point M. I'll go label these x1, y1, x2, y2. Now I can just plug in. 2 plus negative 4 over 2. 6 plus negative 2 over 2. Gives us negative 2 over 2 and 4 over 2. And we're going to simplify. Negative 2 over 2 is negative 1. 4 over 2 is 2. Our midpoint for segment AB is negative 1, 2. Here we want to find the distance between these 2 points. So we'll start by writing the distance formula. And remember, you can use Pythagorean theorem if you want to, but I'm going to do it using the distance formula because that's what we started with this year. So I have x1, y1, x2, y2, and I'm going to plug in, making sure that I don't skip any steps. I got to make sure that I write my square root symbol the whole time. Don't forget the squared. 6 squared is 36. 8 squared is 64. Remember, if one of those numbers was negative, when you square a negative number, it becomes positive, so you'd have positive numbers anyway. And get D is the square root of 100, and I should know what the square root of 100 is. D is 10. Here we have a segment that has one endpoint, that's negative 2,7, and a midpoint that's negative 615. So we want to find the other endpoint. So we'll use the endpoint formulas. There's 2 of them. x2 is equal to 2 times the x value of the midpoint minus the x value of the first endpoint. And then the same thing for y2. And this x2, y2 is going to end up being our answer. We have to write it like a point. So my one endpoint was negative 2,7. That's x1, y1. My midpoint was negative 615. That's my xm, ym. So I can just plug in 2 times xm, which is negative 6, minus x1, which is negative 2. 2 times ym, which is 15, minus y1, which was 7. So I get negative 12. This minus minus makes a plus, so negative 12 plus 2 gives me negative 10. I get 2 times 15 is 30, minus 7 is 23. So I'm going to take these numbers and I'm going to plug them in over here. My answer is negative 10, 23. And that is the other endpoint of that segment. Here I want to find the length of RT. RT is this piece of the picture, and it's x minus 7. These two segments, SR and RT, should add together and when they add together they should make the whole thing, which we see is 37. So we can write this equation and solve it. 2x plus x is 3x. 11 minus 7 is 4. And that's positive 4. So we do a plus 4. Subtract 4 from both sides. And finally divide both sides by 3. And we get x is 11. That's not what we wanted. We wanted the length of our t, so we got to go plug that back in here for x minus 7. So RT is 4. Here we're finding the value of x in this figure, and this figure right here is a pentagon. It has 5 sides. All of these things that are labeled 100, 90, 90, 105, x, they're interior angles. And we can always find out what the sum of the interior angles are for any polygon. And we do that by using the formula 180 times n minus 2. In this case, n on number of sides is 5 because it's a pentagon. It has 5 sides, so we plug 5 in for n. And when we do that, 5 minus 2 is 3 times 180 is 540. So this 540 degrees means that if I add 90 plus 90 plus 100 plus 105 plus x, it should equal 540. So I'll do that. 100 plus 105 plus 90 plus 90 plus x should equal 540. So when I do this, this is 180, 280, 385. So this 385 is all 4 of these angles added up, plus x, the angle we're looking for. We subtract 385 on both sides, and we get that x is, let's see here, do some quick mental math, 155. Here we're finding the value of x. I have 2 vertical angles, and vertical angles we should remember are equal. They're congruent to each other, so the measures are equal. And this is a little bit hard to see. These are plus signs. So if you've checked your answers against mine in class and you got the wrong answer, just check that you use these as plus signs. The copy got a little bit faded. So 13x plus 56 is equal to 11x plus 72 because those 2 angles are congruent. So I can subtract 11x from both sides. Subtract 56 from both sides. Divide both sides by 2, and I get x is 8. Here I have 2 angles 1 and 2 that are complementary. That means that they add up to 90. We want to find the measure of angle 2, so we'll start out by finding x. We'll add those 2 angles, and they should add up to equal 90 degrees since they're complementary. Combining like terms, subtract 10 from both sides. Divide both sides by 8. We're looking for the measure of angle 2, so we can take x and plug it back in here. Put 10 in for x. We can see that the measure of angle 2 is 34 degrees. Here we're trying to find the measure of the indicated angle. That is the one that is labeled with a question mark. And you might notice that that should not say angle. It should say arc. We have an angle. We're finding this arc. So that might have been a little confusing, so I hope I just cleared that up. This angle that's 123 degrees is a central angle. Central angles are always the same degree measure as the arcs they make. So this purple arc that we called question mark is the same as the angle that makes it. So it's 123 degrees. Here we are finding the measure of the indicated angle, so I labeled that correctly. This is an inscribed angle. Because the vertex is on the circle, each side is a chord in the circle, and it intercepts this arc. That's 194 degrees. The relationship here is that the angle, the measure of the angle, the inscribed angle, is equal to 1/2 the measure of the arc. So the angle we're talking about is question mark. The arc we have is 194, so we just divide that thing by 2. And we have question mark is 97 degrees. Here we have a case where we have segments labeled. So this segment is 4. This segment, this is a tangent segment, is 6. The secant segment is broken into 4 and x. This is an outside times whole equals outside times whole problem. For the tangent, the outside and the whole are both 6. For the secant, the outside is 4. And the whole thing is 4 plus x. We're adding the two pieces together. So I'm going to have to do the distributive property over here. 4 times 4 gives me 16 plus 4 times x. Subtract 16 from both sides. And then divide both sides by 4, and I get that x is equal to 5. So that means this whole segment over here, even though that's not what we're looking for, this whole segment over here is 4 plus 5, which is 9. Here I have lengths of segments, but this time these are chords, and the chords intersect inside the circle. So all I do is take the two smaller segments from one chord, so 5 and 8, and I multiply them together. I take the two small segments from another chord, 4 and x, and I multiply them together. And then I solve for x. So x is 10. Here I have two secants, but now what I have is I have an angle here, I have an arc, and I have another arc. So this is a problem where you can say the measure of the angle is equal to the big arc minus the small arc divided by 2. The angle is question mark. If you call it x, that's fine. The big arc is 175. Notice it's the bigger one. The small arc is 57. And now we can just simplify to get question mark. So it is 59 degrees. Here we have an angle again, and we have two arcs. And remember, this is the situation where we can make a bow tie, as we called it in the past. So the angle we're looking for is associated with these two arcs that are part of the bow tie. And the measure of our angle is equal to the first arc plus the second arc over 2. It's important to notice that that's a plus sign in this relationship. So our angle is question mark, and our arcs are 175 and 55. So our angle that we're looking for is 115 degrees. Here I'm finding the area of the sector of the circle. The sector is this sort of slice of the pie. The first thing you need to do is find the area of the whole circle, and this formula is on your formula sheet, and the area is pi times the radius squared. In this case, the radius is 10. So the area of the whole circle is 100 pi. Remember, that's in terms of pi. So the whole circle is 100 pi. We just want to know what this slice is. So we're going to multiply that 100 pi times the percentage of the circle we have. So we can find that out by taking the angle measure, 60 degrees, dividing it by 360, and then multiplying it by 100 pi. That will give us the area of the sector. So you get the area of the sector rounded to the nearest tenth is 16.7 times pi. So notice it's smaller than the original, which was the area of the whole circle. Here we want to write an equation of a circle. The equation of a circle is something that's given to you on the formula sheet, but you should write it every time so you can get practice using it. HK is the center of the circle, so I'm given the center, 2, negative 18, so H is negative 2, K is negative 18. We need one more thing in order to find the equation of a circle. We need to know what R is. And we can find R by finding the distance between the center and this point, negative 8, negative 18, that's on the circle. So I'm going to have to go do some distance formula. I'll use my center as my x2, y2, so negative 2 minus negative 8, negative 18 minus negative 18. So I get 6 squared plus 0 squared, which is just the square root of 36, which is 6. So my radius is 6. So I can go ahead and plug h, k, and r in here. The negative from the h is going to make this a plus 2. The negative from k is going to make this a plus 18. And I can write this as 6 squared. Now I have an equation of a circle. So those were the review problems. These next few problems are the new stuff, the parallel lines problems. Here we want to know which information would verify that L is parallel to M. So in order for things to be parallel, in order for lines to be parallel, we have to know something about the four special angle pairs. So the alternate interior angles, the alternate exterior angles, and I wrote these things wrong. Alternate interior, AIA, alternate exterior, or the same side interior, or the corresponding. So we do have vertical angle pairs and we do have linear pairs, but those don't tell us anything about parallelism. So when we look at these four answer choices, we want to find the answer choice that tells us about one of these four special angle pairs. So x equals 72, that tells us about a vertical angle pair. That's not one of our four special angle pairs. Y equals w, again, those are vertical angles. That's true, but not one of our special ones that makes lines parallel. Z equals 108, that's also true because these two are a linear pair, but linear pairs again do not tell us anything about being parallel. They're not one of our four special angle pairs. So we're kind of left to check and make sure that D is correct. X and W are alternate interior angles, and alternate interior angles must be congruent for lines to be parallel. So answer D would tell us that those lines are parallel. Here we want to find the slope of a line perpendicular to this line. So the first thing we need to do is find the slope, and we'll write the slope formula. So if we find the slope of this line, we can find the slope of a line perpendicular to it. So we get negative 2 minus 1 over 3 minus negative 6. Make sure the y's are on top. Now, that's the slope of the line that we were given. The slope of any line perpendicular is going to be simple to find now. We take this slope and we flip it, so 3 over 1. And since this is negative, we make this one positive. The slope of any line perpendicular is positive 3 over 1. Here we know that these lines P and Q are parallel, and we just want to find the measure of angle 3. If we're given the measure of angle 1 is 6x plus 10, we're given angle 2 is 4x plus 40. Those are alternate exterior angles, so we can say that they are congruent and equal. Do some solving. I subtracted 4x, now I'll subtract 10 from both sides. Divide by 2. This angle 3 that we're looking for is going to be supplementary to angle 1. So if we find angle 1, we can find angle 3. Angle 1 is 6 times 15 plus 10, which is 100. So that makes angle 3 80 degrees because they're supplementary. Here again, I know that C and M are parallel, and we're missing a label here. That's line C. Angle 1 is x plus 40. Angle 2 is 6x. These aren't a special angle pair, but I do know that this angle 2 and this angle here are corresponding, so they are the same, so that is 6x. And therefore, these two are supplementary, so I can add x plus 40 plus 6x to be 180. Subtract 40 and divide by 7. So now we have to make sure we answer in this question. We want to know the measure of an angle that is complementary to angle 1. So we can find angle 1, 20 plus 40. Angle 1 is 60. Complementary means that angles add up to 90 degrees. So an angle complementary to this one is 30 degrees. It's a little tricky. Here I want A and B to be parallel, so I'm actually going to kind of ignore this line here, and I'm just going to look at line A and line B, and this transversal D. I see these two angles here, 110 and 2x plus 30, are alternate interior angles. They should be congruent. That means their measure should be equal. So x is 40. Here I need to graph a line parallel to the line that's given. So the first thing I'll do is find the slope of this line. I'll count up 2 to the right 3. It's a slope of 2 over 3. I want my line to be parallel so it'll have the same slope. It's going to go through this point, so I can just start right here at negative 2, 1 and count up 2 and go to the right 3, up 2 to the right 3, which is the same as going down 2 to the left 3. Now I think I have enough points where I can draw my line. This one's similar to the last one, except we're finding a slope perpendicular. So again, we'll find our slope of this line up to right 3. The slope of the perpendicular line is going to be this fraction flipped with the opposite sign, so negative 3 over 2. So I'll start at my point. I'll go down 3 to the right 2, down 3 to the right 2, and I can keep going. The opposite is going up 3 to the left 2, and I have my line perpendicular. Here I have a diagram where I have a couple parallel lines. These two mirrors, the darkened lines, are parallel. And I have a transversal here. And I'm told that angle 1 and angle 3 are congruent, and angle 6 and angle 2 are 80 degrees. I'm sorry, angle 2 is 80 degrees. We want to know what angle 6 is. These three angles, 1, 2, and 3, should add up to 180. So that means 1 and 3 combined must make 100, since angle 2 is 80 degrees. And 1 and 3 are congruent, meaning they're equal. So if they add up to 100 and they're equal, that makes each of them 50. And I know that 1 plus 2 should equal 5 plus 6, because together they make alternate interior angles. So 5 plus 6 should add up to 130. I know that 3 is congruent to 4. So what I'm going to end up here is with the same three angles. Angle 5 is 80, and angle 6 is 50.